All right, so yeah, welcome. Thank you for everybody for coming. I'm going to give a little overview on Hatco, who we are, where we started, where we came from, give you a little idea of the products that we make, the machines that we have. We'll get into the lasering system, the sorting that we have with the Astes, and get into some numbers and things like that. So I've got kind of the boring part of the presentation, just giving you a little history of the company. Where we came from, again, my name is Dennis Watlett. I'm the manager of the fabrication. I've worked there for 36 years. So I've seen a lot of change from shearing blanks to punching to the automation that we're going to get involved with today, lasering, robotics, different things like that. From there, we moved to Sturgeon Bay in 1973, but we've expanded our product line immensely from toasters to drawer warmers, food warmers. We were voted best in class for 17 years in a row in all three of these fields. Some of the machines that we have a number of different forming press brakes. We've got 13 different press brakes, 4 of them of which have robotics on, 7 have auto tool change, 2 Cincinnati brakes, 2 Salvaghinis, a P2 and a P4. We do some laser welding. We have 2 Trump fiber laser welders. We're looking right now at getting into some of the handheld laser welding. The laser nesting that we'll talk a little bit about in the sorting. We have N-Cell is our integrated, and SortCam is what we'll get into in a few minutes. We also do powder coating. We've got 38 different colors under our roof that we paint. A number of different spot welding applications, riveting, PEM-serters, Hagers, things like that. So I mean, we branch out to a lot of different areas. So prior to 2018, all 4 of our lasers were located in different areas of our fabrication shop. We had 2 load and 2 unload areas, which we would store all of our material on cantilever racks. We had forklift drivers all day long delivering steel to lasers, taking finished cut nests, bringing them to another area. Then we'd have people sorting, finished parts versus throwing away the skeletons and scrap. It was very time-consuming, a lot of labor-intensive things, and we knew we had to do something. We had to get more efficient. We had to reorganize our entire sheet metal shop, which is exactly what we did. We partnered with Mitsubishi to design our rivet system that we'll see, but this entire area at one time, which was just outside storage, parking lot, overflow, maintenance items, was completely enclosed, and that's what housed this system. This is our river. We have 193 shelves, 6,000 pounds per shelf. We have the room designed where our truckers, the semis will come in. This is where we'll load our steel into the river. We have 3 lasers on the north line, 1 laser on the south. At this design, back in 2000, I believe it was 18, we had 3 CO2s and then 1 NX fiber, which was great for that time, but then we ended up needing more laser capability. So we expanded to a GX laser on the south side, eliminating 1 CO2, and this is where our Astes system gets involved. So we will load, the steel will load onto one of 3 different shuttle tables, goes into the laser to be cut, comes back out, processed with there's a 3-shelf system for storage of parts. On the opposite side, we have open to future growth. We're debating, do we go with AGVs? Do we go with a conveyor? We're just not sure what it's going to fit into our system right now. 2 different pallet exchangers for scrap skeletons, so it's quick changeover from one steel to the next. It's kind of an overview of what I was just describing. We've got the laser, we've got the load of blank sheets and the unload of skeletons. Comes back to a 3rd system, which is where the Astes will be involved. There's a 3-shelf system for storage of parts. And again, off to the opposite side, it's kind of an open area. A lot of times we'll stack longer parts that we don't want to place on a single skid. And again, growth for the future. This is what I've been describing. Another overview from the laser to the loading, unloading of skeletons. The pick area, which is the 3rd shuttle table, 3 different areas, 3 different tables that we'll talk about again in just a few seconds. So here's the Astes. kind of an overview. We'll take a look at how it operates. So again, what we'll see is we'll see the arms of the Astes start picking parts. On the inside, you'll see the clamshell unloading. The skeleton remained from the previous nest that was just picked. While this is all going on, the laser in the back is already cutting the next sheet. Kind of a choppy video. As it unloads the skeleton, it'll load a fresh sheet. Has a wire brush that'll come down and brush across the slats in case you ever have slugs or things that stick to your slats. See, it's loading another sheet. As I mentioned, there's 3 different shelves, or what we call as a vault. The sort cam, which we'll get into in a little bit, you can actually dictate what head or what type of application you want to retrieve the parts, where you want to stack it. This is kind of our first stage at organizing the flow through our shop, because we can tell what parts to go on what skid. So if we have a kit, or if we have certain parts that want to go to a certain cell or a certain machine, we can start grouping it at this spot so that the whole pallet goes to one area and you don't need to manually move any kind of flats, any other type of parts. So this sheet just took a little over 2 minutes to sort. Again, the laser's still up and running. I don't think we've ever ran into a time that the Astes, was overworking the laser, that the laser would be waiting. The Astes has always been done before the next laser sheet. As long as you have more than a 2 or 3 minute nest, it's usually done. Another view from the opposite side of the laser. The Astes is in the back. This is the middle shuttle table. The laser's off on this side. Again, we'll see how the wire brushes will come down, sweeps across all the slats. Any slag, any slugs that might be stuck. Gives you good sheet contact to the slats itself. Actually, oops, sorry. Wrong button. I apologize. There was more to that video, but anyways, yeah, that was the overview, the Astes. One part that I did cut out was there was another view from the backside that kind of showed the 3 different pallet changers. Again, I apologize for that. This is an example of the vaults. There is different selections that you may have. We have the 3015, 3 shelves. You have stacking capability up to 5 inches. Pallets themselves are 60 inches wide. You can go up to the 72. So that's all dictated by your factory, your needs. Another view, again, just trying to show you have 3 different capabilities or 3 different options for stacking. These shelves can be used simultaneously, individually, however you want to have it. Many times, if we have larger nests, we will fill all 3 of these shelves. Plus, we may stack on the other side that we still have open. So complete control at the operator's discretion. Just another view, show you the size of everything. You configure what you want on your own, depending on if you want just standardized skids. You can construct one large 10-foot skid if you'd like. We've got a few different options where we have standard skids, one standard skid with a 72-inch skid. So you can really configure any of that upon your needs, part sizes and things. This is the option for the future where if we have longer parts that we don't want to use up the small skids, we can stack on this side to the far left. And again, this is where we're thinking AGVs, conveyor system to have it come directly out to a wide belt deburring, options for the future on how we expand. Different options for your tool and your heads. There's a combination between vacuum systems with suction cups. There's one large cup. There's the multi-head, probably the most used by us just due to the fact of holes and configurations in parts. I believe you have 37 different suction cups in this area. Magnetic, there's one magnetic head, but you can have 2 different settings if you go full strength or half strength. We've also have smaller suction cups, small ovals, different options. So it's really depending on your part size, part weights, part configurations again. Here's an example where all 4 of the heads are used at one time. So you've got complete option whether you use 1, 2, 3, or all 4. It's a little bit longer part, probably about a 5 or 6 foot part, just as an example of how we want to pick it up. A little bit lighter metal. Operators, our operator in a few minutes will get into more of how they select and place. You have control on the floor, where you want to pick up, how do you want to stack, versus just one single head picking up a part. So now that's the end of my presentation. We'll get into some of the programming and operating of the Astes itself, the sort cam, how it works, how it's done. So I'll introduce Roger Young. He's our main laser operator. He's the laser team specialist. He's worked with the installs. He worked.
I'm going the wrong way. Wrong way. This is a little picture of my workstation that we use. This is where the operator was for programming. We are like right in back of it, so we can see everything that's coming off the laser at the time. As you're programming for the day, you can see the machine operate. If I need any problems, if we're having picking problems, anything else in the forward, the guy's right here to see what's going on. If we have a new job to go through that doesn't have any, never been programmed before for sort camming it, we're testing out the cups for mispicks. The operator is able to see that at the time, real time as it's coming off, and we can do adjustments in the background on the programs on the fly if we need to, and we can reload them and rerun them in the future if we want to, for the next sheet or later on or at the time. Our programs change daily, every day, so it's not always the same program, same parts every single day we're doing, so they can change. So it's not like we run the same thing over and over and over where we have the same programs. It's always different. So when we're programming, we can have large programs up to 30, 40 sheets, other programs up 3 to 4 to 5 sheets. So it can change daily. Oops, I need the wrong one again. My average weekly, we spend about 3 to 6 hours per week. We have 3 shifts that do run this. First shift, 10 hours, second shift, 10 hours. We also have a weekend shift that works 12-hour days for 36 hours for Friday, Saturday, and Sunday that operate this machine. Like I said, the size nest changed. The parts have never been, the sort camming can change from something that's very fast, that's been saved previously before, that's already been sort cammed, like parts that have already been run in the past, they're saved in the system. So once you sort cam that, it's already in the system, so you really don't have to go through and re-sort cam any of that stuff for moving the cups. It's already saved previously. So that kind of speeds up the system. Programming the skids can change also. It matters on for us is how large the parts are and how many parts we are running, which can change on a daily basis on the large nest, the smaller nest. A lot of stuff we do as the machine is running, because it's fully automated, is we will unload our skeletons because we run 300 series stainless steel to aluminum to cold roll. And since we only have 2 buffer stations in the back for skeletons, we might have to change them out for what our needs are. So a lot of this is done as the machine is running in the background. So you don't have to have a bunch of operators changing out anything. The one operator can sort cam, get everything done, do his stuff ahead of time, and keep the machine running fully automated and keep it going. Our dumping of skeletons is also all done with the forklift. Our people do not have to handle anything by hand. We try to cut down any hand handling of any metals at all as possible. Kind of cut all of that out. So the machine's doing all the work, everything from the raw end of it all the way to the finished part of it as much as we can until deburring and other operations we have that the product may go to. And of course, we do a weekly file rest. So if you can see the picture, our shop is really clean. We take a lot of pride in keeping everything clean in our area. So that way it keeps any kind of our problems down of message you have for people working in the area to the machinery. If you have any issues, you're working in a clean environment to keep everything clean and organized. And then we can go over the little sort cam process here, automated on the sort cam. So what will happen, we come in, I'll have a nest number. We have a nest that comes in. We have different numbers that'll come in, that'll get released to us from our programmers upstairs. I'll come down and we'll have a list. I will take one of the programs that we have, and we have one here now that we'll have. You have it ready in there?
You ready?
Yep. Put that in there to show a little bit of that.
All right. I'll as you describe it, I'll
Okay, so we'll take the program number, we'll enter the number into the system here. And this one has 17 sheets in it, so we'll highlight the sheets that are running in there. It'll load into our sort cam system. It'll come up, it'll show the sheets on. Each one of these is per sheet, so I have 17 sheets. So 1, 2, 3, if you go down, it'll show the parts that are inside these different nests and what's coming out. And then what I'll do next is I'll go through here and I'll go through the picking, set up the picking process and compute it. So compute the picking. The machine, when you first have this in, will either set it up for you and pick for size of part and complexity of part of what it wants to use for that, for cup sizes and different cups and magnets or whatever you need to use. Or I have the ability to go in here and change it. So as you go along, you may try a part that may compute, may work just fine. It also may not work for flexibility and difference of metals, for picking up, if it's flexing at all, because there are light curtains in this machine, so if it does pick up and it hangs down, it'll connect on that like you're missing a pick part. So that way it will not just pick up and rip your skeleton out of heck and keep going. It'll actually try a couple times, doesn't pick it, it'll reject that part, lay it down, and then go on to the next part. So that's where we can come in and change to different kinds of cups, maybe magnetic, different cups. We have 4 different heads we can use, and we can try different areas and move them all over the place to try to fit any kind of complex part to make sure that that part picks properly. So.
keep going.
Yeah, so. And you compute that, it goes on, and then you can compute it after, say, you go through all the stuff, and you can go through each one of the parts and make sure that that is saved in there. I have usually on the side here, it'll be a little ID, and it'll have check marks on the side that'll show that they're saved in the system. I go through, as we get larger and more nests in this area, we save them, and they're always saved, like I said, they always save in the system. So if a part doesn't run for 3 or 4 weeks and you get a nest that comes into, it'll be in that system. It always remembers it. So as you get more parts in here and more, remember, the sort cam goes faster and faster because you really don't have to change the cup system. It's already saved. It's been trialed and errored, gone through, and you just go on to it. Next step would be for parts picking. It's going to lay out on a table. It'll process what it needs to do, and it'll show where it's going to be putting the parts on the tables we want them to. I have the ability to tell it to go to certain tables if I want to, or I can let it go and populate by itself and let the sort cam do its work, and it can sort cam it and put it on tables it wants to put them on, to either inside out or inside out or outside in, to populate a skid for size. Whatever skid you want to do is from 60 by 120. Like we use a lot of 48 by 40 skids. I have products that go to all different areas of the shop. Some go to deburring, some go to robots that don't go to deburring. So I can actually tell this to stack them parts on certain skids by themselves. So the forklift guy can come in, take them out, and ship them right to the area they need to go. So we're not stuck on just having everything in one skid. I want to cut down any kind of hand operation I can on what the areas this stuff needs to go to. So you have a lot of different options here of where your parts want to go and where you want to go with them. So up to whatever you guys, abilities your company needs or whatever it would be for compared to what we have. So I'm actually happy with the system. I really enjoy running it. It's actually a very easy system to operate. When we first got it, I won't be honest, I looked at this thing and think, oh my gosh, this is going to be so hard. But once you get into it, it's actually very simple. Especially with the saving of the parts, once they're in there, they're saved. I mean, you can adjust things over time whenever you want and save them in there, and they're always saved. So it's a really great program to run for parts over and over again, all the way to new parts. Once it's saved, just go. Been a really, really great system for stacking wise, heights, turning parts. I mean, the abilities of this machine in the future, I see of just where this technology, where I came from, where technology now is just, it's incredible. We used to do everything by hand. I used to punch everything by hand, shear everything by hand, and now I'm in an area where I have robotics doing all the work for me, which is just great. So, anything else? Does anybody have any questions at all for me on this at all?
How are you handling part tip-ups? I'm assuming you're not tabbing the parts to the schedule.
No, these are all not tabbed in. We also have cross-destruct also in our systems that, say you have corners in here, and when you have sheets, especially with thinner materials, you can have some hang-ups in the corners. So we have a system that will cross-destruct around these corners from the laser that allows relief so that when it comes down, you have any movement, there's relief there for it to pick up.
Is there a minimum part size that you need to have for the nest that you direct to that system so they're not falling through your slats?
Yes, I believe it's, what is it, in between slats? 2 inches?
On the slats?
Yeah, I think it's like 2 inches, I believe, something like that. But a lot of our small parts we run into, we blank them into blanks. So I'll make, like say we have a part that's like a half an inch by a half an inch, really small. We put them in little, we call them suitcases. So we'll put multiple parts into a suitcase and have it in the middle there. Either if it's magnetic, I can choose a magnet to pick it up and fill it all up. Or if I want to use a cup for your 200 series or anything that's not magnetic, I'll have an area in the middle that's not cut out that the cup can come down and pick that hole right up and stack them. So your ability to put small parts in here is there too. So.
Minimum part size is 8.
Yeah, minimum, yeah, for minimum part.
8 inches.
Yeah, 8 inches.
8 inches.
8 inches, yeah. But like on here, like I said, I even have parts that are long and skinny that I use my small second cups to pick up because it's a real flimsy little part. It's very small. So we've had adjustments on this for even parts that are, say, really, really long and flimsy that we add metal into the part to hold them together that we can use the cups to pick that entire part right up and stack it and just remove the tabs later if we need to on something that's a difficult pick that's really long and really skinny and light.
What is the range of material that you run through that system to pick this way?
28 gauge aluminized is the thinnest, and the thickest I run is 3/8 stainless. So run really thin stuff and thicker, but not super thick. I mean, most of our heavy users probably 20 gauge, 16 gauge, 22 gauge. That's a lot of 20, 18 in that area. It's pretty much our heavy hitters for our machine here. We operate.
Raj, what's the average of, how many times do you have to manually intervene with a pick and place location or anything versus the software picks the correct?
How many times do I have to like change the cup up?
Right. I mean, roughly.
Maybe a quarter.
Okay.
And a lot of it has to do with me where it wants to go. If I want to manipulate it to a skid or something like that, I mean, it's pretty good because it looks at the weight of the part and the size, and it'll pick that cup that'll work best for that.
But then once you modify it,
Yeah, once you might stays. Yeah, once you modify and save that, it's saved. So every time, if you have an operator that's not, maybe newer on there that can just sort cam, they can sort cam it. They don't have to do any adjustments. It's already in the system. They just sort cam it, go program it, let it go, and you can run multiple programs behind it and keep this thing just running.
Is that per part or per nest? Like, you say your nests are different all the time?
Yeah, per part. Ours is saved per part. So when this part's saved, and this part's saved, all these different parts are saved, they're saved in the system. So when they come out, my nest will change daily. Sometimes I'll have the same part, other times I have different parts. So once they're saved in that system, they're saved. So it doesn't matter what nest comes out, as long as they're saved, they're in there. The system remembers it.
You have scenarios where you ever have the laser head waiting on the sort cam to finish?
Like the laser waiting, the only time that I've ever had that happen if I'm going from one job to another. If I have a lot of small parts finishing up on one nest, and the next nest of a different material's coming behind it, and it's a very fast runner, that's the only time it would wait, and that would only be that one sheet, and once that starts up, it just keeps going. So I never really have a same nest that would be waiting at all for the picking system. Unless there's an alarm or something would happen, would slow it down, the laser keeps running, of course, and something like a scenario like that, which is just, normal.
Do you have any data as far as like decreased injuries by not having to handle skeletons manually anymore?
I don't really have the data on that. I just tell you about how I worked. Yes, it's decreased. You don't have anybody handling this at all, which is great. I'm coming from a guy who's been doing this for 30 years. I mean, like I said, I sheared, punch pressed before we even had lasers. Everything's done by hand. So this is just awesome. Technology is great.
How do you handle expedited components?
We take them off, either by a little hand cart forklift, or we have a regular forklift that goes off on the, if you saw this thing before, we have the tables that can come out, and the backside of the 3 shuttle tables, or the cassettes, they can come out, and the machine keep running. You can bring them out and take parts off, and it can keep operating, as long as it's not using that shelf. And that's how we expedite our stuff. We take it over. We're looking more into robotics down the road, of adding on to like a cobot or something, not a cobot, but like a mirror little robot that can come in and pull a cart out and go to an area if we want to program it to. We're in the process of it right now of looking into that, to more automation of that end of it, of handling. So. Good. Well, thanks a lot, guys, for your time and everything. Appreciate it.
Thank you, Roger. All right, so we're going to talk about the impact on operations. My name is Daniel Moya. I'm the manufacturing engineering manager. I'm new to the company. Been with the company just roughly 2.5 years. Pretty impressed with Hatco. Honestly, I come from Kansas. I come from HVAC industry. When it came to Hatco, the facility's clean. They don't mind investing into equipment, right? So pretty impressed with Hatco the 2.5 years I've been there. So yeah, when we started putting in this GXF and Astes system, right, we had to put together a strategy right ahead of time before the equipment arrived and how we were going to try to manage that. So we started with product. This was a group, a team. We come together, consensus. We started with product that was 8 by 8 and larger, right? We felt like that would be efficient in picking, and that would probably be the easiest, the larger the part. We took the previous 12-month highest usage, and we started with those. And then we also took anything over 100 pieces. So we have a lot of pieces, a lot of item numbers, so we don't make everything every year. So each year is going to be a little different. So that's why we went with the 12-month highest usage.
These are changes you need in preparations for an Astes to pick your flats, and that's remove tabs, slug destructs, earthquake, and so on. Anyway, notch relief, and then clustering of small parts, right? So that's kind of a key task right there also. All right, so this was kind of our timeline as we were ramping up in 2023. So the equipment was installed in January. We first picked parts February 8th was our first picking. And then in the background, we had a team working on prepping these files to be picked on the Astes, right? So by April, we had roughly 1,000 capable of being picked at the Astes. April, we also started introducing flats that were smaller, 8x8, right? Where Roger talked about clustering and suitcasing. So we started testing the waters in that. By August 23, we were up to about 3,500 being capable picked on the Astes. And then July of this year, we were up to 4,200. So these are some numbers. So I did a quick report, pulled down. Like I said, total of Hatco part number flats, we have roughly 11,000. So that's our 100%, right, that we're capable of making. I don't think we discontinue anything, and I don't think Hatco discontinues anything. They can make everything they made the first day they open. So for the year, so 2023 to date, remove flats with no usage. So 40% of the flats we didn't run that year or to date. So that resets my balance, right? So I'm working off the 6,687 as my 100% or my new 100%. Of that, we're currently roughly around 50% of what can be picked on the Astes. Now, if you remember when they were talking about the north line and the south line, right? The north line, we have 3 lasers. The south line, we have the 1 GXF and the Astes picking system. Right, so that's how we separate them. We're comparing the GXF Astes to the other 3 lasers. So yeah, 40% is Astes capable to be picked. Down here, the amount of production, we're roughly 1 million parts to date on the Astes that the Astes has picked. Right, so that's a pretty significant number, and we did have a team in the background that is continually working to prep these files on what flats can be picked on the Astes. So yeah, pretty impressive numbers there. Looking forward to doing even increased. So here's some daily hours. And really this is just comparison between the north line and the south line. So the 1 laser, the 1 Astes, and the other 3 lasers. So we have increased, you can see our dotted line going up. So we have continued daily hours going over to the Astes, and that's really what this chart is telling you, right? So 50 hours daily. And similar to the other line, right? So now we see a decrease. So we have more product going over to the GXF and Astes than we do on the other 3 lasers. So this is a continuous process as we continue on. So these are daily. These are some weekly, a clearer picture of that dotted line, right? Of more hours going to the Astes and a decrease taken away from the other lasers, right? So total number of sheets. You also see an incline here, right? As we're going up at an angle, more sheets are being used and ran on the GXF fiber laser and the Astes picking system in comparison to the other lines where we start seeing a decrease in sheets. So really, yeah, just some graphs on how much effort is being put into what the GXF can do and what the Astes can do. It's really making our job more efficient as far as supporting our customers, which our motto is knock your socks off service, right? That's Hatco's motto. So these are some of the materials. So someone had a question about materials. So this is a summary of that. Cold roll, 22 gauge, 11 gauge, cold roll 3/8, stainless, aluminized. So yeah, quite a variety of product, very thin product that could be ran. And these are some of the benefits that we see. So talking about unmanned, right? The equipment can sit there and run. So we have a punch turret kind of near this system that an operator can sit here and run this punch turret. And then when he needs to come over here and unload the Astes, he can, you know. So it really depends on the nesting size, how long it runs unmanned. But it can run through breaks, lunch, after hours. So yeah, a big labor savings there. Ergonomic improvements, or no, the picking of multiple parts, right? So that's a key point. Ergonomic improvements. So we usually, on the other lasers, we're manually detabbing, right? As far as an operator leaning over a conveyor, and he's really extending his back and trying to get these parts off the sheet, where here you won't see that. And then the awkwardness of larger parts. I think that's kind of an obvious one. Sometimes you'll see two operators going over there and two managing a sheet. So grouping of parts for downstream operations, a benefit. Option to use different size skids, as Roger had pointed out. Hands-free skeleton disposal. Right, so they literally, this is all exiting this automation, and they come up with a fork truck and they dump it into a bin. All right, so pretty nice benefits. So speaking to the future, so you'll see our current system over there on the right. That's our current system running. And here on the left, we have already cut a PO for another system. So we're expecting this to be in 2025, second quarter roughly. So yeah, we'll be replacing one of our CO2 machines, and so we'll have two systems on either end of the north and south line. So that's going to take a lot of our capacity and manage it really well. And the idea is also looking, if we grow or we have major growth, we'll also have room in here to put in a third system, was the plan. So. All right. Appreciate the time you've given us for letting us talk to you about our system and showing you a little bit about Hatco. So thank you for coming, and Q&A. Any questions for me or for MC Machinery? My coach can answer some stuff about the equipment. Roger did a great job answering some questions. So. Downtime, we have not seen a lot of downtime. And if we do, I think if I've seen it down a couple times, MC Machinery has been very supportive in getting it back up and running, right? But have not seen a lot of downtime. Dennis, you?
No, not really. I mean, they're really Johnny on the spot when there are issues. Someone earlier asked a question too about the Astes and the laser, the timing wise. We've already had the Astes turned down to 50% speed, and it was still feeding the laser. So yeah, rarely is it down.
So when they installed the system, they did a great job in alignment and making sure everything was installed as per spec. So really downtime has been very little. But we're what, a year and a half in? So, you know, we don't see what the longevity is going to do yet. Right. So. Yeah, so the skeletons are automatic, right? So the clamshell manages that, it takes them off. So we have a two-table shuttle to the right. And let's see if I can back up here and get you kind of a... All right, so there's a two-table shuttle here. So the clamshell manages the skeleton. It loads it onto these two, either table, and these exit out this way. And then we just literally just fork truck it off here. So we have pallets that it sits them on. We'll fork it off and we'll dump it in a disposal bin. So yeah, very easy.
Spacing between parts, if you're not having these, I'm assuming you gotta leave a certain amount of gap there with wet head collisions.
Roger, you know that? I was thinking quarter inch, but quarter to 3/8, I think is.
Like cut on that, so if you come like cut the parts like right up to it. Yeah, so there you go. Yeah, they come like.
Yeah, I should have brought our programmer.
Yeah. So, next year.
next year. All right. We got 5 minutes for the next group. There we go. All right, you want to? Thank you, everybody.